Okay, good morning. So, we started talking about quadratic equations. I told you quadratic equations are the equation of this form: ax squared plus bx plus c equals to 0. A, b, and c are real constants. They are real numbers. But of course, a isn't 0, because if a is 0, we go back to the first degree equation we already know about it. So we always assume that a is not 0. Yes? But we do not have any constraints anymore. But if you remember, I talked about some special cases. A case in which b is 0, we learned how to do it. We also considered a case where c is 0. We also learned how to do that. If you have forgotten, you can go watch the video. And we also started solving a complete quadratic equation. But if you remember, so far, what I told you is a is 1. And for this case, I gave you two methods. I presented two methods. One method was factorizing it. If you can do some guesswork, guessing two numbers. So for example, if a is equal to 1 and you have this, and you want to solve this, one way of solving the problem is to ask yourself, can I find two numbers whose sum is this number and the product is this number? If the answer is yes, then you can write x, two x's in two pairs of brackets, and then if you guess those numbers are alpha and beta, you put alpha in one of them, beta in the other one. This will give you the factorized form of this polynomial. And when you equate it to 0, based on the zero product rule, either the first one is 0 or the second one is 0, you get your answers, yes? But I told you that sometimes it is not easy to guess the numbers because the numbers are out of reach. So then you have to find another way. Another way, which is always reliable, is the completing square method. And I gave you some examples yesterday. And let me just start with one more example today. And then finally we go to the case if what happens if a is not equal to 1. By the way, a is equal to 1 is not an obstacle. We will come back to this, okay? Okay, so for example, let me give you this equation we want to solve, just to refresh your memory a little bit, yes? So you want to solve this equation. Okay. So here again, if I see this equation, I myself always prefer to use the factorization method, if the numbers are so simple that I can have a guesswork. If not, I will go to other methods. So let us solve it in two different ways to refresh your memory and then continue to the last part of the lesson today. So here, let us use factorization, yes? If you can do the guesswork fairly quickly, and this is possible, I say that factorization is a good way to solve this quadratic equation. So do you remember, if it is possible that I can use factorization to solve this, I need to ask myself, are there two numbers that I can guess so that the sum is positive 2 and the product is negative 15? If you can guess that numbers easily, then you can factorize it by putting x here and there. Okay, can you guess those numbers? Yes, Sergey?
5 and 3.
5 and 3, but the signs should be adjusted. Because 5 and 3 doesn't work. If I add 5 and 3, the sum is 2.
5 minus 3.
Okay, so it should be positive 5 negative 3. Yes? Why is that? Because if I add 5 to negative 3, it is really positive 2. And if I multiply them, it is indeed minus 15. So this guess is correct. And you see, it is completely immediate to answer if you can do this guesswork quickly. And then what are the answers? Either the first one is 0, or the second one is 0, because there is no other alternatives. If the product of two numbers is 0, at least one of them should be 0. And then immediately you get that x is equal to negative 5, or x is equal to positive 3. So these are the roots of these equations. By the way, sometimes this you need to be familiar. When I say a root, I mean a solution. Or what you say nollställe in Swedish, I think. Okay, so you see that factorization method, if possible to guess, is faster. But sometimes it is not possible. Okay, so then what we have to do, we learn another method, which is completing the square method, yes? Okay, in the completing the square method, do you remember what I'm supposed to do? I move, for example, 15 to the other side, so it becomes x squared plus 2x is equal to 15. Then the goal is to add a number to both sides so that the left-hand side becomes a squaring pattern. And I think this is very, very simple to guess the number, but if the number is a little bit complicated, I gave you the rule of thumb. What was that? You take this number, divide it by 2 in your head, square it. So if you divide this number in your head by 2, it becomes 1, and if you square it, again becomes 1. So the number that you are supposed to add is 1. So you add 1 to both sides. This becomes 16. And this number is now a squaring pattern. And then don't get confused. What is the number whose square is 16? There is not one number, there are two numbers. One of them is positive 4, or the other one is negative 4. If x plus 1 is 4, the answer is 3. If x plus 1 is minus 4, the x is minus 5. So these are the roots of these equations, which squares with these, yes? These are the answers. So that was what we learned. Okay, today I want to actually relax this condition and say that, okay, if a is not equal to 1, then what I'm supposed to do. I think you can do it yourself. For example, in principle, you should be able to answer it yourself, yes? If I give you this equation, so that's the most general form. So if I give you this equation, 2x squared plus 3x minus 5 equals to 0, and I ask you to solve this equation. So what I'm supposed to do? First of all, factorization method. Of course, if you have checked my videos, I teach you there how to factorize this. But it takes more time, actually, I would say, in general, than if you know the formula and put the numbers there. So whenever this number is not 1, factorizing this is a little bit problematic, and you don't study that. So I don't want to bother you about the factorization method. So then it means that I have to use completing a square method. But completing the square method will work fine if this number sitting in front of x squared is 1. So far, all the examples that I gave you for this case is the case that a is equal to 1. This is the first example that a is not equal to 1. But I think you can tell me what to do. Assume that you don't have the teacher, you want to solve this one. The only difference is that this starts with the 2 rather than 1. So what should I do? Yes, Ali?
Divide everything
by 2, yes. And then I will go back to the previous problem. Because this is equality, be careful. I have seen, if I give you something like this as an expression, still I see some students get confused to divide by 2. You cannot divide by 2 unless you also multiply by 2. Yes? But if I have equality, then I can divide both sides by 2, saying that if you say this is equal to this is clear that half of this is also equal to half of this. Remember the logic, yes? So here, as you said, we can do that. If I divide everything by 2, this becomes x squared, this becomes 3 over 2x, and then this becomes minus 5 over 2, this becomes 0. So, I am no longer solving this equation, I will be solving this equation, but this equation and that equation are equivalent even though they are not identical. Why they are equivalent? Because if x satisfies this, I multiply it by 2, x also satisfies this. And if x satisfies this, I divide by 2, x satisfies this. Yes?
So like, if one of the sides is equal to 0, you're still allowed to multiply and divide however much you want the other side.
Yeah. Because if you say that this number is 0,
it almost feels like cheating, but it's nice if it works.
No, it works because they are equivalent. Yes, if you say a is 0, this is mathematically equivalent. So let me change the letter. Don't get confused here. So a is 0. This is, if a is 0, this is guaranteed that a divided by 2 is also 0. Now, if someone tells me a divided by 2 is 0, I can also conclude that. So this means that these two statements mathematically are equivalent. Yes? Okay, so that's the case. Now, of course, the numbers are not so friendly anymore because I have to work with fractions, and you have to work with fractions, yes? In this case, 3 over 2 is exactly 1.5, but try to get used to working with fractions, okay? But you already know how to solve it, yes? Because now what I did, by what Ali mentioned, I reduced this new problem to a problem that I already know how to solve. So, okay, how should I do that then? I move minus 5 over 2 to the other side. It becomes positive 5 over 2. Then I have to find the number so that when I add it to both sides, the left-hand side becomes a squaring pattern. And I told you the rule of thumb. What is that? If you want, you can go to scratch paper. You have this number, whatever it is. You divide it by 2. What is the number? It is 3 over 4. And then you square that number. It becomes 9 over 16. So this is the number that you are supposed to add. So this becomes x squared plus 3 over 2x plus 9 over 16. So that is the only number that you can add to the left-hand side to make it a squaring pattern. And then I have to add the same number to the right-hand side to compensate for this change that I made to the left-hand side. Okay, now what happens? If you have calculated this correctly, don't doubt about it. Of course, it is better to double check, but this is always this squaring pattern. This is positive, so I put positive. Then I take the square root of this is x, take the square root of this is 3 over 4. I really recommend you to double check everything. So let us raise it to power 2. The first one to power 2 is x squared, that's correct. 2 times the first times the second. This 2 and this 4 are cancelled, so it becomes 3 halves of x, which is correct. And the second one to power 2, that's also correct. But on the right-hand side, I take the common denominator, yes? So the common denominator between 2 and 16 is 16. 16 divided by 2, 8 times. 8 multiplied by 5 is 40. 16 divided by 16, 1 times. 1 times 9 is 9. And of course, this becomes 49 over 16. So you see, I am not doing something new. The reason it was a little bit more complicated than the previous case is that this number was a very simple number. In this case, I have to add this number. But everything is completely the same as before. And now you have something to power 2 is equal to this number. So this means that x plus 3 over 4, there are two options for this number. Either that number is 7 over 4, so that when I raise it to power 2, it becomes 49 over 16, or x plus 3 over 4 is negative 7 over 4. And I'm looking for x. So I move this to the other side, so x becomes 7 over 4 minus 3 over 4, which becomes 4 over 4. So x is 1. This is one answer. And then I move this to the other side, x becomes negative 7 over 4, negative 3 over 4, which becomes negative 10 over 4, but I always simplify, so it becomes negative 5 over 2. So these are the answers of this, these are the roots of this equation. Yes? Is that clear? So I would say that everything regarding the quadratic equation is actually finished here, because whenever I give you a quadratic equation, the completing the square method works for all cases. Yes? So you can always learn the squaring rule, completing square method, but I don't recommend you. You can use this trick for the other cases where b is 0 where c is 0. But for B0, C0, there are simpler solutions. So don't do this. Only do this when you have the complete form of a quadratic equation. Any questions? Okay. But the point is that, let me give you another question. I want to wait for you to see how you just do that problem. And then I will continue. Because you see, the power of algebra is this. Whenever something appears a lot in your work, instead of doing it from scratch every time, the good point is that we can do it algebraically once for all to get a formula. Okay? And then we will do that one as well here. But because I want to make sure that you actually learn this method, I want to give you another example to see how it works. Okay, so solve this equation for me. Let me just randomly write some things. 3x to the power of 2 plus 5x minus 7 equals to, so let me make it this, yeah, minus 7 equals to 0. So these, these numbers are not friendly at all, and I want you to keep the exact form. That is intentionally I made the numbers. So these numbers that I chose myself at the end were friendly a little bit, yes. But here they are not friendly at all, so you have to work probably with the square root signs and things like that. Okay, just continue with that. I want to find I want you to do the exact value, to determine the exact value. Okay, could you solve it?
Yes.
Yes? Okay, so the numbers, we have to be patient to work with them, but of course the problem is not hard. But remember, whenever this number is not a 1, if you want, you can divide by that. I think it's better to divide by that. So you divide by 3 first, it becomes x squared, and then you will get 5 over 3x, and then you get minus 7 over 3 equals to 0. Then you get to the problem. So you see, in this case, you have to use the fractions, because 5 over 3 will continue forever if you divide. So you are not allowed to write the decimal points. You have to keep the exact values. And then I move these to the other side as I did before. And then that is the time that you have to add something to both sides to make the complete square, the squaring pattern appearing here. So what I have to do, if you cannot do it in your head, you go to the scratch paper, you take this middle number, whatever it is, you divide it by 2. What do I mean by dividing it by 2? I mean that I multiply it by the reciprocal. So then it becomes 5 over 6. Whatever you get, you square it. Yes? So it becomes 25 over 36. So that is the number that you're supposed to add, yes? So I add that number to the left-hand side. I have to add the same thing to the right-hand side to compensate the change. But then if you have done everything right, this is always a squaring pattern. And then I recommend you to double check all the time. So this middle term is positive, so this is positive. You take the square root of this in your head, it becomes x. You take the square root of this one, it becomes 5/6. Let us double check. This one squared is this one. 2 times the first one times the second one. These 2 and that 6 are simplified. I get 5/3 times x, which is exactly the correct one. And then the second one squared is definitely that one. So what we have done is completely right. And on the right-hand side, I have to take the common denominator. Between 3 and 36, the common denominator is 36 itself. 36 in your head divided by 3 is 12 times. And I multiply 12 by 7, which is 84. And then 36 by 36 is 1 times. 1 times 25 is 25. And then if I add them, it becomes 109 divided by 36. So how many of you could come to this point? Yeah, that's good. If you haven't got to this point, please let me know if you have real trouble. You might have done some miscalculations. That's also important, but at least not conceptually important. Okay, so we get here. But now, this is the part that we have to be careful. I have 2 roots, not 1 root. So let me just do it patiently here. So what I do, I would say that, let me change my way of writing a little bit. So this becomes x plus 5/6 is equal to plus or minus the square root of 109 divided by 36. Yes? But here, if I take the square root of 109, I have to keep it in the exact form. But square root of 36 is just 6. Yes? So it means that there are 2 problems that I have to take care of. One is with the positive sign, one with the negative sign. Okay, I'm looking for x, so I move this to the other side. If you want, you can leave it like this, or if you prefer, you can make it as a common denominator, so that I keep writing it like this. So this, I hope that you agree, it was not possible to guess such a strange number for the root of that equation, yes? Another one, I move this to the other side. Yes? I hope that you immediately understand that I can, if I want to, you can leave it like this, that's okay. But I prefer to write it like this. Be careful, when I put the negative sign behind the fraction line, this minus sign is for the whole numerator. And that is correct, because minus sign should be for this one because I have a negative. Minus is also for that one because I have negative. So you see, I get another answer to this. These are the only roots and exact roots of the equation that I gave you in the beginning. So you see that if you want to follow the squaring, completing a square method, you will get the answer. It doesn't matter if you have A, B, and C, any number that you like. And this is the only one that I accept from you. Here or here doesn't matter. But if you write approximate values, that is not acceptable. I want you to write exact values. Is that clear? Okay. Let me give you another example. So, and then gradually we start solving this algebraically once for all, yes? What we do, let me solve this, ask you to solve this. So we have 3x squared, and then you have minus 2x, and then you have plus 5. Yes, equals to 0. I want to spend a little bit of time on this one as well. There is a point in this problem, I want you to catch it yourself first, yes? So to solve this problem, I am looking for a real number x, so that when I replace x with that number, the left-hand side becomes equal to 0 exactly. Okay? So I pause recording, wait for you. Okay, so what did you get? Yes?
There are no solutions.
There are no solutions. So that was probably, it's a very, by the way, that's actually a success, yes, because how on earth we could convince ourselves that no one can find any x so that this will work, yes? But we can be confident now that there are no solutions. How? Let us see. We follow the same strategy to see what happens this time. I divide everything by 3, so it becomes x squared minus 2/3 x plus 5/3 equal to 0. Then I move 5 over 3 to the other side. And then I go to scratch paper. I divide this number by 2. You can take the negative sign into account, but it doesn't matter because at the end you have to raise it to power 2. So you take this number and then divide it by 2, which becomes 2 over 3 multiplied by 1 over 2, which is 1/3. And then you square it. So it becomes 1 over 9. So the number that I have to add is 1 over 9. Yes? I add 1 over 9 to the other side, to both sides. On the right hand side I have minus 5 over 3 plus 1 over 9. But the left hand side now becomes a complete square pattern. But because this is negative, this time I have to put negative. And then this becomes x 1 over 3. Why is that correct? The first one is squared, that's correct. 2 times the first one times the second one gives me exactly the middle term. And the second one squared gives me positive 1 over 9. So everything is right. But on the other side, I have to take the common denominator, which in this case is 9. 9 divided by 3 times. I multiply it by minus 5, it becomes minus 15. And 9 divided by 9 1 times, I multiply it there, it becomes that. But look, this number becomes minus 14 over 9. So it means that I am looking for an x so that when I put this number here and square it, it becomes a negative number. But we know that this cannot happen, yes? Whatever x is, the square of the whole expression cannot be a negative number. So here, you don't say the problem is wrong, you say that there are no solutions.
But Baba,
Yes?
if you make a mistake that you think you can solve this and give an answer, that would give no points in it.
No points, yes. Now might be, if you have done the completing the square part right, yes, you will get some points, of course. If I can break the problem. Yes. So you see, you have to go up to here and say that there are no solutions. So you see, this is very common in quadratic equations. Remember, either we have 2 solutions or we don't have solutions. Let me also give you another example. Wait for you to see how it goes. So 8x squared plus 8x plus 2 equals to 0. I want to wait for you again to see how it goes. I want you to solve this one as well. Thank you. Okay. So what's the answer?
Negative 1 over 2.
There is only one solution in this case, and that is negative 1 over 2. Yes? Okay, let us check. As usual, we divide by 8 to get rid of this factor. If I divide by 8, this becomes x squared. This middle term becomes just x. This becomes 2 over 8. But instead of 2 over 8, I write 1 over 4. And that's equal to 0. So I move minus 1 over 4 to the other side. Of course, if you have a sharp eye, you can detect the square pattern right away. You really don't need to bother. This is a squaring pattern itself. Yes? Because that's x plus 1/2 to the power of 2. If you cannot, I just want to tell you, so if you really know what is going on, so you can immediately collect it into the squaring rule, because this is already a complete square. Yes, I can write it in that way. The first one to the power of 2, 2 times the first one times the second one becomes exactly x, and the second one is squared. So if you can detect it immediately, you really can save some time for yourself and write this. If you cannot detect it, then you follow as usual. You move 1 over 4 to the other side, and then you go to a scratch paper. You take the number in the middle. This is nothing written here. It means that is 1. You take the middle one divided by 2, it becomes 1/2, and then you square it. It becomes a quarter. And that is the number that you have to add. You see, you get the same thing, yes? So even if you cannot realize that this is indeed a complete square itself, and you want to follow the method, you will go back to the same line. You know, if I add 1 over 4, then I get back to 0 again. So then I would say that this becomes x plus 1/2 to the power of 2 equals to 0. So I really want you to be able to immediately detect that this one is indeed the case, rather than going through this step and going back to the same point. But then x plus 1/2 to power 2 is 0. How many numbers are there so that their square is 0? There is 1, and that number is 0. So this means that x plus 1/2 should be 0. There are no, you can write plus or minus the square root of 0, but the square root of 0 is 0, and plus minus 0 is always again 0. So that is 0, and then you get x equals to minus 1/2. So in this case, you see, even though I have still a quadratic equation, I have one solution. In the previous case, I had a quadratic equation, I had 2 solutions, different solutions. And then in this case, I had a quadratic equation and I didn't have any solutions at all. So this is the problem, you need to get used to it. If I give you a quadratic equation and you are supposed to work with real numbers, then these are 3 scenarios that you might face. No solutions, 1 solution, or at most 2 distinct solutions. And one thing that I want to mention here, this single solution is not called a single solution, it is strangely called a double root. Yes? It's this number, whenever you have one solution, you call it a double root. The reason for this name is because of the multiplicity of the roots, yes? So for example, if I write x plus 1 to the power of 3 equals to 0, let me make it simple. X minus 1 to power 3 equals to 0. You get one root, and that root is 1. But this is called a triple root. The reason is that, in principle, this means that I write it 3 times, and then because of the 0 product rule, either this one is 0, or that one is 0, or that one is 0. This is called algebraic multiplicity of a root. So this means that x equals to 1 appears 3 times. So that is why it's called a triple root. I just want you to know the name. So whenever you have one single answer, you call it a double root. Okay? Because of that reason. Okay, now I think everything is now settled down. And we have enough time. So I want to do it once for all algebraically to get a formula, and I really recommend you to memorize the formula, even though you can always get it. May you please close the door? Thank you. Thank you very much. Okay. I really want you to memorize that. But there is also another problem. I don't know, for some reason in Swedish tradition, they don't use the standard formula. They use what is called PQ formula. I really don't like PQ formula for the reason that I want to tell you, because in PQ formula you have to always make this coefficient equal to 1. And then if you want to use PQ formula, then you have to work with fractions. That's up to you. I will teach you both. That is up to you which one you want to choose. Both of them are in the formula sheet, yes? Both the PQ formula and what I call ABC formula. Okay, I want your help because I want you to understand this, not just memorize that. Even if you just memorize it, it will work for solving, but not for understanding. Okay, so what we want to do, we want to do this algebraically once for all and get the formula, okay? I'm sure that you can do it, but you need to pay attention to the details of derivation of the formula. Okay, so if you don't mind, let me call it ABC formula for the time being. ABC formula. So I give you a quadratic equation, ax squared plus bx plus c equals to 0. And I told you that when I say that this is a quadratic equation, I implicitly assume that a is not 0. Because if a is 0, I will have a first degree equation. Okay, now help me to do it. Assume that these letters are numbers and you want to use the completing square method to solve it. What is the first thing we did in the previous cases? Yes?
Divide by a.
Divide by a. To make this coefficient 1. So I divide everything by a. So this becomes x squared. This becomes b over ax. This becomes c over a. The right hand side becomes 0 over a, but 0 over a is 0. The second step was, if you remember, to move this term to the other side. Yes? So I will do the same thing. So this becomes x squared plus b over ax equals to minus c over a. But then if you remember, we went to scratch paper. We take the middle term and divide it by 2. I take the middle, not middle term, the middle coefficient, b over a, I divide it by 2. Dividing by 2 means multiplying by 1 over 2, and what you get is b times 1. You have to be careful because we are doing it algebraically. So it means that I have to work with letters and variables. 2 times a is 2a. And then in a scratch paper, do you remember, whenever I got this, I square it. When I square it, I square the numerator, which becomes b squared. I square the denominator, which becomes 4a squared. Okay, so the scratch work is done. So then I realize this is the number that I have to add. Yes, I add that number. So this becomes x squared plus b over ax plus b squared over 4a squared. I have to add the same thing to the right hand side as well. So this becomes minus c over a plus b squared over 4a squared. So you see, I am exactly following the same method, but this time I am working algebraically. I am working with letters and variables rather than numbers, yes? No questions so far? Okay, so hopefully you realize the pattern here. So what is that one? Definitely, this is a squaring pattern with the positive sign here in between. Okay, what should I write here and there? Can you help me to write it? What should I write here first? It's very easy. What's that? That's definitely x. But what is the next one?
B over 2a.
B over 2a, yes, thank you. So b over 2a. I told you that always double check. So if I want to make sure, the first one to power 2 is really x squared. 2 times the first one times the second one. These 2 and that 2 are cancelled. I get b over ax, b over ax. That's correct? And the second 1 to power 2 is indeed this one. So that's no word. That's completely true. And then on the right-hand side, we have to take the common denominator. For the numerical case, you have enough experience. So can you tell me what will play the role of the common denominator between these two fractions? So I want to take the common denominator. So what should I put in the denominator here?
4a to power
4a squared, thank you. Yeah, 4a squared is a good choice. Okay, I have to do some calculation in my head. Let me do this one first, which is easier. 4a squared divided by 4a squared becomes 1 time. And then 1 multiplied by the numerator becomes b squared. So this is b squared. And then I have the negative sign here. So I put negative sign. And then again, 4a squared in your head. Or of course you can go to a scratch paper. 4a squared, you divide it by the denominator of this one. What is the answer?
4a.
It's 4a. And then you have to multiply this by its numerator. 4a multiplied by c, I can just write 4ac. Now here it's a little bit tricky because I am working with letters. I don't know the magnitude of b, a, and c. So there are 3 possibilities that can happen. One possibility is that because this number, we don't know the number, these are variables, so I really don't know if this number at the end is positive or 0 or negative. And it differs with the situation, yes? So it actually matters in this case. So let us consider 3 scenarios. One scenario is that b squared minus 4ac is positive. Okay? If this number is positive, can I claim the whole expression is positive? If yes, why? If b squared minus 4ac is positive, can I claim the whole expression here is positive? Yes?
Yes.
Why?
Because the denominator is definitely a positive.
Positive. Because denominator is 4 times a squared. A squared is always positive.
And 4.
Times 4 is positive. So the denominator is guaranteed to be positive. If the numerator is also positive, the whole number is positive. Yes? And then I want to look for it. So then it means that x plus b over 2a is equal to plus or minus square root of this number. B squared minus 4ac divided by 4a squared. I go one more step. This means that x plus b over 2a is equal to plus or minus. But the square root of a fraction is the square root of its numerator, which I have to write it as it is. But the square root of the denominator is what? 2a. And then I am looking for x. To make x alone, I have to move this to the other side, and I am done actually. So x becomes, if I move it to the other side, it becomes minus b over 2a plus or minus square root of b squared minus 4ac divided by 2a. This is the form that you get it in the formula sheet. But I myself prefer to combine these two into one fraction. That's up to you, okay? I myself always use this. So I put the 2a as the common denominator, and then I will have minus b plus or minus the square root of b squared minus 4ac. So this is the formula that I memorized when I was at your age, okay? For solving the quadratic equation. But this is the one given to you in the formula sheet. I combined them. They are exactly the same thing. Is that understandable? I want to do the derivation, but I will summarize them at the end. So if b squared minus 4ac is 0, sorry, is greater than 0, then definitely I will get two answers. One answer is this with the positive sign. Another answer is the same more or less with negative sign.
Wait,
Okay?
Papa,
Yes?
why did the b became minus?
So I moved this was positive.
Yes.
When I moved it to the other side, it becomes negative.
I
And then when I take the common denominator, still this negative sign is for b.
it was the b over 2a.
Yes. Yes. It was minus b over 2a.
Yes. Yes.
Yes. Okay, now this is one scenario that might happen, number one. Number two is when this turns out to be 0. Sometimes this might be 0. So might be that number is 0. Number two, it might happen that by coincidence this becomes 0. What happens in that case? On the right hand side, if b squared minus 4ac is 0, it means the numerator is 0. The denominator is of course not 0, but 0 divided by any number is 0. So then it means that I will have x plus b over 2a squared is 0. And then there is only how many answers? One answer based on the terminology I introduced. This is called the double root. So then it means that x plus b over 2a is 0. And this means that x is minus b over 2a. Double root. And by the way, you don't need to memorize this a second time, because if b squared minus 4ac is 0, this totally vanishes and you write minus b plus or minus 0. But minus b plus or minus 0 is just minus b divided by 2a. And then what happens if coincidentally, based on the numbers in the problem, this turns out to be less than 0? This might happen. And then what is your conclusion?
No solution.
No solutions. Yes. Why? Because this expression, if it is negative, its numerator is negative, the denominator is always positive. Negative divided by positive is negative. On the other hand, x plus b over 2a to the power of 2 cannot be a negative number. So in that case, you would say no solutions. So that's more or less the end of the story of quadratic equations. So we were able to find a formula that can generate the roots of a quadratic equation in all possible cases. Yes? And there is a name for this guy. And I see that Swedish name is also the same, but probably different, a little bit different spelling. That's called discriminant. Discriminant is not an English word, it is a mathematics word. Yes? Discriminant is something that you can calculate and indicate something with some indicates a mathematical property for you. Okay? So for example here, if I calculate b squared minus 4ac, it indicates something for me related to my problem. If this number turns out to be positive, I immediately realize I have two solutions. If it turns out to be 0, I realize that I have a double root, one single solution. And if it is negative, I realize that there are no solutions. Something like this is called a discriminant in the problem. Discriminant means something that its calculation is rather easier than the original problem, but it indicates something vital and important for the main problem. Yes? That's called discriminant. And I think in the Swedish you have the same thing with letter K instead of C. Okay. So I will call it discriminant, and it is common, a little bit unfortunate, it is called delta. This delta has nothing to do with delta y, delta x in this case. So usually we use delta for showing a change in something, But that is also common, especially if you see older books. They call it delta or discriminant of that. So it has nothing to do, I have written it in some way, it has nothing to do with this delta. Yes? Nothing to do with delta in this formula. Okay, so if I want to summarize, I will do like this. But you really don't have to follow me. In mathematics, be creative yourself, so you can follow your own path. But this is what when I have to teach, I have to follow something, so that if, from pedagogical point of view, you can follow that. Okay, but always you should be creative yourself. So if you want to solve this equation, I recommend you to do this for the people who want to follow instructions. But I want you to emphasize, you have to be creative yourself. You need to find your own way to do things. So if you give me to solve that, and I intend to use this formula, I will do this. I will calculate delta first, and I memorize it, by the way. I calculate delta, and then I know that because delta is just a number, there are three possibilities for that delta. Possibility number one is that delta is positive. If delta is positive, then I would say that the x that I am looking for is minus b plus or minus square root of delta divided by 2a. So that's not a waste of time to calculate this. Because in this formula, you see, you need this combination. So you calculate this. If it turns out to be positive, I get two values for x. One with positive sign and one with negative sign. I have seen in some books, they write it like this. That is completely understandable. So they write 1 and 2. Because there are two roots. X number 1, x number 2. That's also possible. Then number 2. It might happen that you calculate delta and it turns out to be 0. So if delta is 0, you have only one double root and the formula is minus b over 2a. And finally, if I calculate and find delta is less than 0, probably it's easiest. No solutions. So I would say that this is the complete summarized version of what we have done. You have to know this for the exam, but you don't need to know the proof if you don't like to. But it is important if you want to learn mathematics to understand where the formula is coming from. Otherwise, that would be just a set of soulless rules, one after the other. Okay, any questions here? Okay, so for example, I don't know if, no, unfortunately, yeah, we have only this one left. But let me give you another. Still, don't forget about the other methods. Yes, if you have factorization available for you immediately, I myself prefer to do factorization again. But this is the end of this problem. Whatever you give me for A, B, and C, regardless if these numbers are friendly or not, I can definitely use this formula and solve it. Yes? But I am not saying that this is always the best. Usually, if you are creative, you can factorize this, you get it quicker, faster. But now, if you want to write an algorithm for a code or something, you can put this formula in the computer and then you are safe on the safe side because you can get the roots all the time. Yes?
I have a question.
Yes,
so
please.
For the first case,
Yes?
yeah, why does it say x1?
Because I told you there are two roots. One with positive sign, one with negative sign. I don't stick to putting 1 and 2. You see, I have changed the color. Some books, they write it x1 and x2. It means the root first number root number 1, root number 2. But which one is the first, which one is the second, it's arbitrary. Yes? Is that clear? Okay, so I want to stop. I don't want to continue. Might be that was quite a lot of information. But if I don't give you one single example at least to how to see how it used, it is useless. I just give you one example and I will complete it on Thursday. Okay, so for example, if I give you this equation, 5x squared plus 7x minus 12 equals to 0.
How about one thing?
Pardon?
On Thursday we don't have any.
Yes, I will continue it on Friday. Okay, so we want to solve that one. Be careful. If in the exam I implicitly mention do the completing square method, you are not allowed to use this. But if I don't mention anything, I myself prefer to do this. Yes, that's up to you. In that case, you can also use the completing a square method all the time. But the point is to learn this to actually save some time. Okay, the first thing that I want to do, I want to explain it completely in details. So if I want to use this formula, I need to understand what is A. So what is A? Can you tell me?
5.
5. What is B? 7. And what is C?
Minus.
Minus. This is extremely important to consider the negative with the number itself. The second thing I can calculate, I memorize the formula for delta, which is b squared minus 4ac. And I put those numbers here. So this becomes 7 to power 2 minus 4 times 5 times negative 12. And I calculate it. So this becomes 49 plus 240. Yes? Minus 4 times 5 is minus 20. Minus 20 times minus 12 is 240. And if I add them, it becomes 289. So how many solutions you predict now? Because this is the first scenario, delta turns out to be a positive number. It is 289. So this means that I will definitely have 2 roots. Yes? So then I need to have the formula of the roots in my head. I really want you to memorize that, okay? So this becomes plus or minus a square root of delta. I intentionally repeat the formula so that you can have the opportunity to memorize. Because we understood where the formula is coming from. I didn't just write it on the board and say memorize it. We derived that. After we derive it once, if you want, you can repeat it once more for yourself at home. But after a while, you have to memorize it. Otherwise, every time you have to refer to the formula sheet. Okay, so then what happens here? Minus is in the formula itself. B is 7, so this becomes minus 7. Plus or minus square root of delta, which I already did it, divided by 2 times A. So 2 times 5. So that is, I am just following the formula. And if you put this number in the calculator, you get 17. So this becomes minus 7 plus or minus 17, and then 2 times 5 is 10. And then I would recommend you to write it in that way. That's up to you how you want to write it. But you have to consider 2 scenarios. One with the positive sign in between. One with the negative sign in between. Yes? So with the positive sign in between, I get 10 over 10, which is 1. With negative sign in between, I get minus 24 divided by 10, which is minus 12 over 5. I am done. So the answers, one of them is 1, the other one is negative 12 over 5. So I hope that you agree with me. This is the end of the story of the quadratic equation. But the interesting thing is that you might ask what will happen if I increase the degree to 3, if I increase it to 4. It turns out that for the case 3 and 4, we can get formulas complicated a little bit more complicated, sorry. But it turns out that we don't have such a formula from 5th degree onward. Yes? If you give me a 5th degree equation with all the terms present there, Norwegian mathematician Abel showed that this is not possible. We cannot find a formula that gives me all the roots of a fifth degree equation in general. I can have a fifth degree equation knowing the answer, yes. For example, x to the power of 5 minus 1 equals to 0. That is a equation of fifth degree, but I can solve it easily, yes. I move 1 to the other side, and then I see that there is only one number, and that's 1. That's done. But if I write all the coefficients, for example, if I write x to the 5 plus 3x to the 4 minus 3x to the 3 plus 4x squared minus 5x plus 1 equals to 0, then you shouldn't expect a formula that gives the roots of this equation. Yes? So this is why quadratic equations are important. So this is possible all the time. We got a closed formula, a formula that gives the roots of this equation depending on the coefficients. We do not have such a formula for fifth degree equations on the board. Yes? Any questions? Okay, so I would prefer to stop here. You can have 5-minute break or something and then go back to work. Okay, thank you.